Hey, how's it going? Andy from Seldon here. It's Giovanni from Seldon.
It's Giovanni, yeah.
Yeah, and I've got the new T-shirt on.
Me too.
Yeah. So
it's not new, but
just do it later. No, mate, come on. You need to be wearing the Seldon shirt.
yeah, sure, next time.
But the intention for the video today is to talk about model explainers, machine interpretable AI, XAI, whatever you want to call it. You know, people have been talking about this buzzword now for over a year, and to be honest, for me it was like quite a high level conceptual thing, but now what's happening is, and one of the messages for today is, really companies are starting to invest real money into explanation, how explaining algorithmic decision making and actually making it visible, visualized for users in companies to actually use. So companies are now investing in this kind of section of their pipeline, which would say, I think it would come on a pipeline after the training environment.
Sure, yeah, it will. Now, since Andy tricked me into doing this video, I'm just going to tell you about something that explanation, it comes at prediction time, I would say, Andy.
Okay, prediction time, yeah.
So after the training.
So would that be once the model's actually
the model is trained?
The
model is trained, is in production, and you use it to make predictions or classification. You don't trust what the model is saying, for example, for some reason.
Yeah.
And you want to know why the model is predicting what it's predicting. Then you can use these tools that these open source tools, Python tools that we build Seldon.
Okay, cool. Yeah, so am I right in saying, so we've been figuring out how to really articulate a return on investment. So if I'm a company and I'm going to spend loads of money on, visualizing explanation for algorithms, how do you generate an ROI from that? Well, if it's a heavily regulated, say, use case, say in finance, then when a model is actually built by a data science team and then they want to get it live, it has to go through a compliance team, and the compliance teams and directors are very nervous that they don't really know why the model's making the decisions that it is. So it's taking months to get through compliance teams. So if they can explain the prediction essentially in real time, then they can know what's going on inside the black box, and B, they can trust the deployment and actually release the model. So that would speed up time to market models. And then I think the other one is there's a dog coming towards her. and another one would be, if it's a consumer-facing use case, you need to give the consumers instant feedback on why they were given a certain decision. Yeah. That would be another one. And then the third ROI level would be avoiding fines from GDPR. But moving away from the commercial side, so what is this alibi library you guys have just released, and how is it going to help companies?
It's a Python library, so to use it you need to know just basic Python. You just call, it's very simple to use. You don't need access to the details of your model, because it's a black box explanation library that deals also with black boxes. That means prediction function, where you don't know the structure, what's going on inside. That's why it's called a black box. So you will use techniques which are anchors, contrastive explanations. There are some techniques that in literature, scientific literature, that are been out recently.
Yeah.
And that's it basically. And it's supposed to be very good.
Okay. But just drilling down on that, because some people watching, they're trying to figure this stuff out. So I mean, what is, a lot of people talk about SHAP and LIME techniques. What are those other techniques, and why are they why are they helpful?
Well, for example, in Alibi we have anchors, which is the successor of a Rhyme, basically. So Rhyme is quite old now. Anchor is quite similar, but it's better. So because it came out last year, I think.
And then why is it better?
It's just an improvement. It's technical, I can tell you, but it has a lot of tweaks and improvements that help, that makes better explanation of Rhyme, basically.
Okay.
It's not local, basically. It's not this issue with locality is called.
Okay.
Line, but anchors kind of overcome this somehow. And sharp is another popular one. Yeah, that is future attribution, which will be in Alibi soon. Is still in development. Something like sharp. But
Okay. Okay. Cool.
yeah.
Okay.
Then
So.
we have the counterfactuals explanation.
Okay. Tell me about those.
Counterfactual is like when you say what would have happened if. So you have a model that make a prediction, and for example, you have the model will deny the loan to a customer, and the customer may go and say why my loan was denied, but he may also ask what should I change in my features, in my attributes for my loan to get approved.
Ah, okay. I
And
like
the
that.
counterfactual is just address that. So it tells you which feature should you change in your input vector for the prediction to flip, for example.
Oh, okay, nice. So does that imply a way to optimize the model then? If that feedback loop would go back to the data scientists, or that's more it's more giving more accurate feedback or more helpful feedback to
It's
the
more about
consumer.
it's more about an explanation, like the consumer, the counterfactual instance. So it would be the explanation. It says your loan was denied because your annual income is too low.
Ah, right, yeah.
And so the counterfactual would be if you had a higher annual income, your loan would be approved. Maybe it's not the best example
Yeah.
because this is pretty obvious, but
Yeah.
you can go on other cases where
Okay.
it's the first that comes to mind.
Okay, actually, I've got a good example. So there's two use cases I'm exploring with the company for explainers. The first one is HR. So the algorithm actually predicts which people and classifies which people should be offered a job. And then also the other one in this big company is using our algorithm like a model to predict where to allocate internal resources for a project. And on both counts, they require explanation to justify the decision, avoid lawsuits. There is a bias detection use case in there as well.
Can be used as a bias detection too.
Yeah, exactly, yeah. Oh, right, it can.
It can be used in principle because you say if the counterfactual instance says the prediction is loan denied, but then it says if you were a woman, your loan would be approved. This would be a reverse bias issue. That
Yeah,
is,
same with the HR thing as well.
It would be detected, for example.
Same with the HR thing.
Yeah, for
Yeah.
example.
Okay, nice, man. All right, cool. Well, look, we don't have much more time now, but in terms of Alibi, so Alibi is on GitHub. It's an open source library for model explanations, and you can use that with Seldon Core, which is a machine learning deployment platform, open source. So run your models in Seldon Core and then apply the explainers on top, or they can just use it as a separate component. Is that right?
No, it's actually a separate component.
Okay.
Andy. So it's independent from Seldon. Seldon Core is about deployment.
Okay.
Alibi is really about explanations. So
Okay.
it can be used. It's very easy to use.
Cool.
If you know some Python, check it out.
Wicked. All right, guys. Well, Giovanni, thanks for your time.
All right, thank you.
I didn't trick you into doing the video. I put, yeah.
I was checking that.
But all right, cool.
I'm kidding.
Cheers.